All right, well, good afternoon, everyone. My name is Eric Frankiel. I'm the CEO and co-founder at MemSQL. Very excited to be here today. We'll be talking about building real-time predictive applications using in-memory architecture. We'll be doing this as a panel, and I'm going to introduce our panelists for the afternoon. We'll start off with Mike Zappieri, who's a software architect at Akamai. We're going to start next with Ian Hansen, who's a software engineering manager at DigitalOcean. And last but not least, we are going to introduce Noah Zucker, who's VP of Engineering at Novus Technology Partners. So with that, we can jump into just a little bit of a prelude and introduction, and then we're going to let the panelists actually talk about how they're implementing and using in-memory architectures today. We're all here because I think we're looking at the next phase of big data. We've looked at volume with HDFS. We've looked at how to store petabytes of data. But the real next innovations are going to be happening along the velocity element. As we take in more data, we have to process it even faster to hit the same SLAs and the same levels of engagement and analytics that we expect in our businesses. Not only that, we have more devices. Everyone has a mobile phone. I think 1.25 billion users are now logged into Facebook every day. And when you launch applications, they're not being used by just dozens of folks. They're being used by hundreds of analysts and companies and millions of users for consumer applications. And of course, users just demand more. Everything works so nicely on a consumer app. Why can't enterprise applications have the same level of performance? And what we'll find in this panel is that those that actually push the boundaries of big data by going faster, by getting access to real-time data, are actually getting a step ahead of the competition. At a high level, MemSQL is focused on real-time analytics. Just last week, we launched MemSQL Streamliner for Apache Spark. This works with streaming data sets so that you can ingest lots of data quickly and manipulate it with SQL. But at our core, part of our technology has always been predicated on an in-memory database that can work with data with full consistency, with full transactionality, and with full scale, leveraging commodity hardware. As we looked across the big data space, of course, adding a column engine was in the cards, and that's part of what we do with data warehousing by actually taking the data that's hot, and as it cools down, putting it right onto a column store so that you can still analyze it and do trend analysis, for example. In terms of sort of the applications and trends that we're seeing today, it really does focus principally around real-time analytics and operational analytics. In finance, you might see that as risk management. Within ad technology, you'll see that as real-time bidding and attribution, personalization, and segmentation. And of course, portfolio tracking across a variety of instruments. Just doesn't need to be financial. But across the board, it's all about monitoring, detection, and response. If you can't respond in the moment, your users might be leaving without an opportunity to see an upsell, without an opportunity to actually optimize their experience. So what we're doing here is actually taking your business and making it work as fast as the user itself is engaging with your business itself. Internet of Things is very exciting, and we can jump into a few of those use cases a little later in the Q&A. But Apache Spark is a really critical component of this, and we'll jump into that a little bit later. I encourage you guys to stop by the booth. We're at 831, and you'll see how this real-time engine is letting you get all the best of streaming with transactional semantics for perfect down to the last transaction analytics.